Welcome to Civil Projects of Onumoy. In the second part of provision of joint, we shall share some valuable knowledge as the purpose of joints are different. Joints will be such way that the architectural view will not hamper and the filler material will prevent all leakage. The position and type of joint will be in views. Here, expansion joint between two building blocks shown in plan. It is an alternative method of treating expansion joint in walls. From aesthetic consideration, it is necessary to cover the joint with covering sheets which may be of aluminium, hardboard, timber plank or AC sheet. The sheet covering is firmly fixed to the wall on one side of joint with the help of rowel plugs and screws provided at 300 mm center to center and fixing through oval shaped slots to the wall on other side of joint. The oval shaped holes permit the movements at the joint without damaging the covering sheet. Here, XX section of previous plan shown with details of expansion joint at roof level. The maximum center to center spacing of expansion joints in all continuous external and internal masonry walls should not exceed 30 meter. The width of joints should preferably not less than 15 mm. The joints should be provided from the top of the wall to the top of the center foundation. In case of masonry wall rests on pile foundation, the expansion joint should be taken up to the top of the grade beam of the pile foundation system. From previous XX sections, details of D is the details of expansion joint at first floor level and details of E is the detail of expansion joint at foundation level. In long chachas, balconies and parapets etc., the expansion joints may be provided at center to center spacing of 6 to 12 meter. The expansion joint in sunset slab should to stop at a distance of 5 cm from face to the wall in which the slab is embedded. However, the percentage of distribution reinforcement in embedded portion along with the 5 cm wide strip of slab from the face of wall should be increased to 0.3% of the gross cross-sectional area. The gap of the expansion joint in the chaja slab should not be filled with any material. In case of covered veranda slabs, the expansion joint may be spaced from 12 to 14 meter center to center. The joint should not extend beyond the wall and its gap should be sealed with water bar and sealing compound. To prevent cracks in masonry above or below the expansion joint, it is desirable to provide vertical butt joints in masonry supporting the veranda slab right from the plinth level. In situations where it is not possible, RCC or plain concrete bed blocks should be provided in masonry below the expansion joints in slab. Where veranda slab is to be cast at the same level and in continuation with the floor slab of the room, the percentage of distribution reinforcement in the portion of slab resting on masonry should be increased to twice its normal amount. In framed construction, it is necessary to have two frames, one on either side of expansion joint. The treatment to be given to the joint is same as applicable to joints in masonry construction. Here is the details at A and B mentioned in previous plan of RCC frame structure showing expansion joint between two columns. Mentioned in XX section of the same details at C showing expansion joint at roof level. Here, the details at D and E mentioned in previous section XX from plan of RCC frame structure showing expansion joint at first floor level and foundation level respectively. Here is a sectional plan showing details of vertical expansion joint in the wall of reservoir. Provision of vertical expansion joint should be made in walls at a center to center spacing of not more than 30 meter. Since expansion joints also function as contraction joint, there should normally be 3 contraction joints between any two expansion joints to meet the requirement. Here, the location of isolation joint between two building blocks shown. Provision of isolation joint also becomes necessary to separate out the foundation of machines from rest of the structure to avoid transference of dynamic or other type of stresses from the machine to the structure. In general, the isolation joint is provided to take care of horizontal or vertical movements of the adjacent building parts without causing damage to the building. In a reservoir where the roof slab is supported on the walls, the movements at each vertical joint in the wall will induce sympathetic movements in the roof slab. Unless similar joint is provided in the roof slab and that too in the same alignment, the roof slab would be liable to crack. Hence, it is important to note that joints in contiguous walls, floors, or roofs should be arranged to coincide. Proper arrangement of joints is so vital that all joints should be clearly indicated on the working drawings prior to start of work, and no intermediate joints should be permitted during construction. The recommendation regarding provision of joints in different component of reservoir as per the latest revision of IS 3370. It is necessary to provide vertical contraction joints at a center to center spacing not exceeding 7.5 meter. The joints may be in the form of partial contraction joint or complete contraction joint. This is the detail of contraction joint in floor of reservoir. To permit free movement, the floor slab of reservoir resting at or below ground level is cast over a bottom layer of concrete, normally of M10 mix. The thickness of this layer of concrete should not be less than 75 mm. A layer of suitable building material is provided over the lean concrete to facilitate free movement of the floor slab above. It may be noted that in both cases, no gap is provided for the joint but only complete on partial separation of the adjacent section is created. The third form of contraction joint is the dummy joint. In this form of a joint, a groove is created in the concrete member to act as a joint. The depth of the groove being 1/3 to 1/5 of the total thickness of the member. These are the details of sliding joint at first floor level and roof level. A typical example of this joint in the treatment given to the RCC slabs and beams on the masonry walls. In order to facilitate free movement of the component at the joint prior to the casting of slab, a 6 mm thick layer of the rich cement plaster 1:3 finished with neat cement is provided over the area of bearing on the masonry walls. The bearing plaster is then finished with a thick coat of lime wash or covered with craft paper. After casting, the sides of top of the slab and beams in connect with masonry are painted with a thick coat of hot bitumen. This treatment prevents physical contact between the surfaces of concrete and masonry and also permit movements of the building parts by sliding action. This is details of sliding joint between the wall and floor of a reservoir. It is obvious that in monolithic construction, the movement at each vertical joint in the wall will have a tendency to induce similar movements in the floor slab. Hence, the wall and floor joints should be in line except where sliding joint is provided between wall and floor. Here is the details of relating to formation of construction joint. From considerations of structural stability, it is necessary to ensure that construction joints are provided at predetermined locations. It is kept in view that the construction joint should be located along or near the plane of minimum shear. The joint should be vertical or horizontal as the case may be, except that in an inclined or curved member, the joint should be at right angles to the axis of the member. The concrete at the vertical joint should be finished against a stop board specially fixed for the purpose. As far as possible, a key of tongue and groove type should be provided at all construction joints. The key is normally found by fixing beveled a strip of wood to a stop board. In case of large works, key made up of sheet metal is used to permit repetitive use. There is a tendency to provide more depth for the key. It is however seen that key formed by use of a 25 into 50 mm beveled edge strip is sufficient for slabs ranging from 120 mm to 180 mm is thickness. The stop board has to be slotted to allow reinforcement to extend from the old concrete to the new one. If the new concrete is to be laid within 48 hours, the face of the old concrete is cleaned with wire brush and water, and a coat of cement mortar of the same composition as that of concrete is applied before placing new concrete. If the new concrete is to be laid after 48 hours, the face of the old concrete is first roughened by chiseling. It is then cleaned of scum, loose aggregates, and other foreign matter, wetted, and a coat of cement mortar of the same composition is applied before placing new concrete. The horizontal construction joint in walls should be located at the top of plinth, top or bottom of window openings, or at any other convenient height. In case of concrete or RCC walls, the location of horizontal construction joint is governed by convenience in setting the formwork and ease of access for compaction and supervision of concreting. The continuity at the joint is achieved by the formation of key. The key is formed by use of beveled edged planks on the inner face of wall shuttering. Prior to pouring concrete above the joint, the beveled edged planks are removed and the surface of old concrete is prepared. In case of wall of a reservoir, the height of the lift while concreting the wall should normally not exceed 2 meter, and hence a horizontal joint in the form of construction joint has to be introduced between any two lifts. For large structures, the contraction joints should be provided at center to center spacing varying between 4.5 to 7.5 meter in two directions at right angles. Thus, the maximum size of floor panel should normally be not more than 7.5 into 7.5 meter. In case of the floor slab is reinforced, it is desirable to discontinue the reinforcement at the contraction joint. The floor panels should be cast alternately in chessboard fashion. The adjacent slab panels should preferably be laid after a gap of 7 days. The joints should thereafter be shown to a depth of about 20 mm and filled with molten lead or joint sealing compound. Isolation joints should be provided at junction of floor with columns, walls, etc. This takes care of the horizontal movements due to contraction as well as vertical movement due to difference in unit soil pressure under floor and columns, walls, etc. To accommodate thermal movement, expansion joints should be provided at intervals of about 30 meters. In case of floor slab of factories where there is possibility of wheel trolleys moving across the joints, the edges of concrete face on either side expansion joint should be protected by steel angles. As a summary, we can say cracks caused due to dimensional movement in concrete on account of temperature and moisture changes, by differential expansion in thick members due to heat by hydration, by uneven settlement of structure, and in the tension zone of concrete member when it is subjected to loading or pressure. Thanks for watching. If you like my video, then please like, comment, share and subscribe.